Hey guys, so in our last lesson, we learned how to do mole-mole problems, and they're called mole-mole problems because in the problem, they tell you a number that's in moles, and then they ask you to find another number that's in moles. So it's called mole-mole problems. And we talked about what moles are, that they're a unit used for counting atoms of different elements or molecules, and then a mole stands for this huge number of atoms. In this lesson today, we're going to go ahead and we're going to take the next step, and we're going to talk about what are called grams problems. And you call them grams problems because they're going to give you a number that's in grams, and they're going to ask you to find another number that's in grams. So we're going to talk about why we need to be able to do these problems, and we're going to talk about how we go ahead and do them. So our target is to be able to solve grams problems. So let's get to that. Okay, so when I'm doing these kind of mathematical problems involving, amounts of different substances, these stoichiometry problems, you can only go from one substance to another substance in these problems using moles, right? The step from one substance to a different substance has to be done in moles. But the issue is, I don't have an instrument in the lab that can count atoms, right? I don't have an instrument in the lab that can tell me how many moles of the substance there are. But I do have one that can tell me how many grams of a substance there are, right? I can use a scale to measure my substance and see how many grams it is. So, we can come into a lab and we can measure grams, and then we need a tool that can help us convert grams of a substance to moles of that substance. Okay, so let's talk about how we get from grams of something to moles of that same substance. Okay, the way that we go from grams to moles is right up here. Okay, we've talked about the periodic table and what kinds of information you find in the periodic table. We've talked about this quite a bit, but one number we haven't talked a whole lot about is the number you find in the bottom of this box. I'll put one right up here so you can see it a little bit more closely. The number that you find in the bottom of this box is what's called the atomic mass. It's also sometimes called the molar mass. Okay, this is how much one atom of that element weighs in atomic mass units, but it's also how much 1 mole of that element weighs in grams. Okay, so for example, if I have sulfur up here, you can see sulfur, it's about 32. There's a decimal there, 32 point something. We can round these off, and that's fine. So I look at sulfur and I say, oh, it's about 32. What that means is that 1 mole of sulfur atoms, listen to that closely, that's going to be very important. 1 mole of sulfur atoms weighs about 32 grams. So I can set up some fractions with these, okay? I can take this number and I can say this many grams in one spot in the fraction, and then 1 mole in the other spot, okay? Because 1 mole weighs that many grams. For sulfur, it's about 32. Each different element is a different amount. Okay, now, of course, not everything that we deal with is just an element, right? Sometimes we deal with compounds in these problems. Like, for example, what about aluminum fluoride, AlF3? Okay, well, this is as simple as just adding up the elements that are a part of it. So let's say I have aluminum, which is about 27 grams. 1 mole of aluminum is about 27 grams. And fluorine, which is about 19 grams. So 1 mole of fluorine is about 19 grams. And if you look in the formula, I have 1 aluminum and 3 fluorines. So I'm going to add up 27 plus 19 plus 19 plus 19. And that'll give me the molar mass for aluminum fluoride. So let me grab my calculator. And I'm going to do 27 plus 19 plus 19 plus 19, or if you prefer, plus 19 times 3. And I get about 84. So aluminum fluoride would be about 84 grams for each mole. So if I'm trying to do this with aluminum fluoride, then I would put 84 grams in one spot in the fraction and 1 mole in the other spot. And you can do this for any chemical compound. You can just add up their elements to find their molar mass. Okay, before we go ahead and look at some examples of a grams problem, I first want to introduce you to the map. Okay, as we keep doing stoichiometry problems, they're going to become more and more complex. And before we get too far into it, I want to show you the map, because right now it might not be that useful because we're still in fairly simple problems, but it gets much more complex pretty quickly. Okay, so first, here's the map. You start on this side and you go to this side. So the question asked you about some chemical, and you're going to find over here what unit you started with, and it's going to ask you a question about a different chemical, and you're going to go to the unit over here that it asked you about. So the problems we did the other day, the mole problems, you start with moles of your starting substance, and you go to moles of your ending substance. And you can see it's just one step there. And you can see on the arrow here, I've written what tool you use to make that step. So to go from moles of one substance to moles of another substance, you use the chemical equation. And you guys remember the other day taking coefficients out of the chemical equation to set up your fractions, right? Okay, now today we're going to do grams problems. So you're going to start with grams of your starting substance. That'll be your first fraction, is the number that they gave you in the problem. Okay. Your second fraction, you're going to use the periodic table to set up. You're going to use these numbers, the molar mass that we just talked about from the periodic table, to set up your second fraction. And that'll give you moles of the substance you started with. Okay. You're then going to go to moles of the substance they asked you about by using the coefficients in the chemical equation. Okay. That'll be your third fraction, is using the chemical equation to set up with those coefficients. You'll then have moles of the substance they asked you about, and then you'll go to the periodic table, use the molar masses to set up a fraction about the substance they asked you about, and that'll be your fourth fraction, and that'll get you to grams of the substance they asked you about. So these problems, these grams to grams problems we're going to do, will be 4 fractions long. You'll go from grams, you'll use the periodic table to set up a fraction. Then you'll have moles. You'll use the chemical equation to set up a fraction. Then you'll have moles of a different substance. You'll use the periodic table to set up a fraction. And then you'll have grams of that other substance, which should be what the question asked you to find. And as we go forward, we'll add some of these other things, and we'll learn about some of these other things later. All right, all that said, let's go ahead and take a look at an example of a grams to grams problem. Okay, this one, it says how many grams of aluminum fluoride, AlF3, will be produced from the reaction of 3 grams of aluminum. And you can see right there underneath that we have the chemical equation for that reaction. So just like every stoichiometry problem, we're going to start with the number they gave us in the problem. And you can see in the problem they gave us 3 grams of aluminum. Okay, so what I'm going to do is I'm going to start with three grams of aluminum, and I'm going to write 1 in the denominator. Okay, I'm going to put times. I'm going to set up another fraction bar. Okay, now because I have grams, what I'm going to do is I'm going to go to the periodic table and I'm going to look up the molar mass for the substance. Okay, and it's just aluminum, so I don't have to add anything up. I will find aluminum and I'll see what is its molar mass, and it's about 27. It's about 27 grams to 1 mole. So in one spot, I want to put 27 grams, and in the other spot, 1 mole. So think for a minute, which place would be a good place to put the 27 grams? You see we had grams up here, so I'm going to want grams down here. So down here I'll put the 27 grams of aluminum, and up here I'll put 1 mole of aluminum. Okay. Whenever you get these numbers off the periodic table, it's always going to be 1 mole in one spot in the fraction. It might not always be on the top, it might be on the bottom, but there will always be a 1 mole when you use these numbers off of the periodic table, because that's the mass of 1 mole of the substance. Okay, so now these cancel. Now I have moles of aluminum. I'm going to want to go to moles of the other substance. So let's look back at the problem and see which substance did they ask me about, and let's look at the chemical equation and get the coefficients for my third fraction. On the bottom, I'm going to want moles of aluminum. And if we look at that chemical equation, we can see 2 moles of aluminum. So on the bottom here, I'm going to put 2 moles of aluminum. And then the question asked me about AlF3. So I need to look in there, and in the top, I'm going to put how many moles of AlF3. If you look at the equation, it says 2 moles of AlF3. So let me put that on the top. Okay. Now I see moles of aluminum and moles of aluminum. I can cross those out. Okay, we're getting there. We've got 3 fractions set up now. At this point, what we're going to want to do is we're going to want to go for our 4th fraction, go back to the periodic table, and we want to find that molar mass for AlF3. Coincidentally, that just happens to be the example I used earlier for how to do it, right? So if we go and we add up 1 aluminum and 3 fluorines, we get about 84 grams. So that's about 84 grams of AlF3 and 1 mole of AlF3. So remember, every time I add these numbers up from the periodic table, the other spot is 1 mole. So looking at this one, where should I put the 84 grams? Should I put it on the bottom? That wouldn't make sense because I have moles on the top. So I'm going to put that 84 grams on the top of this fraction. And then on the bottom, I'll put the 1 mole. And that makes sense and works out because up here I had moles of AlF3, and down here now I have moles of AlF3. So let me cancel those out. And we have our 4 fractions set up. I've gone from grams of aluminum to grams of aluminum fluoride. So now what I'm going to do is I'm going to grab my calculator and I'm going to work this out. So I'm going to take 3 times 1 times 2 times 84 divided by 27 divided by 2 divided by 1. Just as a matter of a mathematical fact, you can skip anything that's a 1 because multiplying by 1 or dividing by 1 doesn't change the number. Okay. So now I got about 9.3 there. We'll round that off too. So I put 9.3, and it's 9.3 what? It's 9.3 grams of aluminum fluoride. And you can take a look back at the question. The question had it ask us how many grams of aluminum fluoride, and now we can answer 9.3 grams of aluminum fluoride. So there's our first example of a grams to grams problem. Before we move on and do another example, let me just point out a couple of things about this example we just did. Some of you might recognize, those of you who are good at math, that here I had a 2 in the numerator and here I had a 2 in the denominator, and you might be good at math and say, oh, those cancel. I don't have to punch those in my calculator. And you're absolutely right. If you're good at math and you can recognize that, good for you. Go for it. Do it. If you're not good at math and you don't see those things, that's okay. It'll come out the same, right? So go ahead and punch them in the calculator. It'll still work out. No big deal. The other thing I want to point out is that sometimes questions might not ask you to go from grams of one thing all the way to grams of the other thing. Sometimes they might ask you to go from grams of one thing to moles of the other thing. And in that case, you'll notice right here at this step, we had moles of the chemical they asked us about. It's totally perfectly fine to start your problem and go through it until they get until you get what they asked you for, and then stop and do the math. So if the question had asked us for moles of AlF3, I would have stopped right there, not set up this fraction at all, and then just done the math. That would have been a 3 fraction problem, right? In the future, using the map, we'll do 5 fraction problems and 6 fraction problems, and they'll look long and they'll look complex, but it's really not that hard. You just follow the map and set things up the way that I showed you, right? So let's go ahead and let's look at another example of a grams to grams problem. Okay, last example in the video here. This one says if 56 grams of nitrogen are used in the reaction, how many grams of ammonia are produced? And you can see the chemical reaction there. It says N2 plus 3H2 react to form 2NH3. That NH3 is the ammonia. So how are we going to go ahead and set this up? What should we start with? We should start with that number they gave us in the problem, which was 56 grams of nitrogen. So (56 grams of nitrogen over 1). Okay. Now, if you notice, I have grams to start with. So the first thing I'm going to do is I'm going to go to the periodic table, and I am going to add up the molar mass for nitrogen. And if you look at the box for nitrogen, nitrogen's molar mass is about 14. And it's N2, so we'll do 14 plus 14. So it's about 28 grams. 28 grams to 1 mole. So where should I put 28 grams and where should I put 1 mole? I will put the 28 grams on the bottom so that it matches with grams on the top here. And then I will put the 1 mole up on the top. And then my grams and my grams cancel out. Set up my third fraction here. In my third fraction, I'm going to the chemical equation. I'm going to go to the chemical equation, and on the bottom I'll put moles of nitrogen, and then on the top I'll put moles of what they asked me about, and that was the NH3. So looking at the chemical equation, you can see how many moles of nitrogen. Well, there's not a number in front of it, which means there's 1. So down here I'll put 1 mole of nitrogen. And then on the top, I want moles of what they asked me about, which was NH3. And you can see in the chemical equation, there's a 2 in front of NH3. So I'll put 2 moles of NH3. Okay. And then in my fourth fraction, I'm going to go back to the periodic table, and I'm going to add up the molar mass for NH3. Okay. You can see that the nitrogen is 14, just like it was before, and hydrogen is 1. And I've got 3 hydrogens. So I'm going to add 1 nitrogen with 3 hydrogens. So I'll do 14 plus 1 plus 1 plus 1. So that's 14, 50, 67. It gives me 17 grams. So am I going to want 17 grams on the bottom here? That's not going to make sense because I have moles up top here. I want moles down here. So I'll put those 17 grams up on the top. And that's grams of NH3. And then, of course, because I used the periodic table to set that up, I'm going to put 1 mole in the other spot. So 1 mole of NH3. And that makes sense. I have moles of NH3 over here. So I'll cancel these. So I forgot to cross those ones. Okay, so now it's all set up. The question asked me to find grams of ammonia, and here I have grams of ammonia. So I'll get my calculator out and I'll do the math. So I'm going to write the answer down here because I'm running out of space over there. And let me see, I've got 56. I'm going to skip that one, times 2, times 17, divided by, I'll skip that one, divided by 28, divided by, and those are both ones, so I'll skip those. So I got 68. So my answer here is 68 grams of NH3. And there we are. All right, so there is how to do a grams to grams problem. We are going to, the next couple of things we learn aren't going to make the problems any longer. The next couple of things we do, we'll answer some questions about chemical reactions using this kind of four-step process, right? After that, though, we'll make the problems a little bit longer. They won't be harder, they're just longer. It's really all it is. So hopefully that helps us be able to solve grams problems. So until next time, take it easy.